what I'm going to focus on right now is evaluating log expressions. This is an extension to what we have done in the past. So the problem that I'm going to ask you to look at is evaluating log base x of 6. Now, this is different from others we have done because you are given, instead of a base, that's a number, you're given base x. So if you look at what you are given as a definition, it's saying that we are going to let log base x of 2, we're going to let this expression equal 0.3562. And we are also defining log base x of 3 as 0.5646 and log base x of 5 as 0.8271. Now, what we're going to need to do is somehow rewrite this 6 in terms of 2, 3, and 5. Well, if you can think about that, 6 is really log base x of 2 times 3. Now, I'm trying to figure out what decimal value this will be equal to. Well, if you think about the log properties that we did before, if there are values in the argument that are multiplied, we can break them up by giving each one of them their own logs. So I'm going to write this as log base x of 2, and because of the multiplication, I'm going to add the logs. Log base x of 2 plus log base x of 3. Now, you are given decimal values above. Well, log base x of 2 is equivalent to 0.3562, and log base x of 3 is equivalent to 0.5646. So if we use our calculators and we add those together, 0.3562 and 0.5646, that sum is 0.9208. So it's saying that this expression, log base x of 6, is equivalent to 0.9208. Okay, let's try another example. I'd now like you to evaluate a ratio. So we're going to look at log base x of 5/3. Now, if you remember your log properties, a quotient, when you're divided, is the same thing as a difference of two logs. So I need to start by looking up here. I have a definition for log base x of 5, and I also have a definition for log base x of 3. So with the first one, when you were given log base x of 6, you had to rewrite the 6 in terms of 2 and 3, so you could use these definitions. For this one, I already have a definition for 5 and 3. So now I'm just going to go through and break up my log. So again, I can rewrite this as a difference of two logs. So I can write this as log base x of 5 minus log base x of 3, because a difference in the argument is the same thing, a division or quotient in the argument is the same thing as a difference of two logs. So log base x of 5 was defined as 0.8271, and I'm going to subtract log base x of 3, 0.5646, and if I check that on my calculator, 0.8271, and I'm going to subtract 0.5646, I end up with 0.2625. So going back to my original problem, that is telling me log base x of 5/3 is equivalent to 0.2625. Now, these decimal values are ones that I just made up. Because you are not given a value for the base, I just selected 3 different decimal values to help us work through these problems. Okay, we're going to try one more example. Let's say now I ask you to evaluate log base x of 40. Well, this one's going to be a little bit more challenging because you are not able to just look at the 40 and see a 2, a 3, and a 5. So I have to figure out a way to break up that 40 in terms of 2, 3, and 5. So if I think about that, I know that 40 is the same thing as 4 times 10. And 4 is also 2 times 2, and 10 is also 2 times 5. So I'm going to rewrite that argument as 2 times 2 times 2 times 5. Or to clean it up a little bit, I'm going to rewrite it as 2 cubed times 5. Now, this problem is similar to the first example where these two values in the argument are multiplied. So if values in the argument are multiplied, you can break them up by giving each one its own log. And I'm going to add those logs together. So I have now log base x of 2 cubed, and I'm going to add that to log base x of 5. Well, when I look at this now, this one's good to go. I have a definition for log base x of 5. I also have a definition for log base x of 2, but this 3 up here is kind of confusing me. So instead of keeping that as an exponent, I'm going to move it in front as a coefficient. And I'm going to rewrite this now as 3 times log base x of 2, because exponents and coefficients are interchangeable. And I'm going to add that to log base x of 5. Now I'm ready to go and make some substitutions. I know that log base x of 2 is this decimal value, and log base x of 5 is this decimal value. So doing some substitutions, log base x of 2 is 0.3562. And I'm going to add that to log base x of 5, which is 0.8271. So let's multiply that out. I'm going to take this product and add it to this decimal value. So let me enter that into my calculator. And I ended up with a sum of 1.8957. So that means that this expression is equivalent to this decimal value.